Hi everyone, welcome to this new video of diving deep into the designing of URL shortener. So in the previous video we have discussed the high level designing of uh, URL shortening and URL redirecting. We have spoken about API endpoints like post API calls or get API calls. The post API call is used to actually shorten a long URL, and the get API call is to retrieve a long URL from a given short URL. So in this video we will look into four main topics. One is the data model, or how the long URL short URL pair is actually stored in a database or in disk or in memory. Second, we will be diving deep into the hash function, which is used to convert or get a hash value from a long URL. Third, we will be looking into the URL shortening, how URL shortening happens, and fourth is URL redirecting. So we will be diving deep into the details of how the things happen in a system architecture. So first let's start with our data model, which is the first topic of today's. So data model. So as we have seen in high level designing, we have discussed like everything like short URL, long URL pair is stored in a hash table. Like if you remember, we have discussed in the previous video, like we have a hash function which takes a long URL and we get a short URL, and then using this short URL long URL pair, using this as a key, we can put it into a hash table. But the thing is, in most of the scenarios and in general cases, it has been observed that the hash table is implemented in memory. Hash table in memory, and thus due to resource limitation, it is not highly scalable. To increase the memory size, it incurs a huge amount of cost, so this is not highly scalable. So rather what we can use is, like when things are not working in memory, then we move to disk. As you know, this is our basic fundamental rule. So we can choose like non-relational databases or relational databases depending on your use case. In non-relational databases, what happens is, like one of the major disadvantage of non-relational databases, example of non-relational databases is maybe like Cassandra or DynamoDB or Redis, which is an in-memory cache. So non-relational databases, the major disadvantage is it has eventual consistency, and this might not be a good feature, or this might not support your use case. Suppose you're handling with critical data and two long URLs are maybe for the time being are mapping into a same short URL. So, and ultimately with time it maintains the consistency, the fundamental principle of eventual consistency. You can go through my video of inconsistency resolution discussed in the playlist of designer key value store. I will put a link in the description box for this. So yeah, so this is one of the major disadvantages of non-relational databases depending on your use case. So what we prefer is like relational databases, where they have strong consistency. And in relational databases, how they are stored is like we have an ID, unique ID, which acts like the primary key, and then we have the short URL and the long URL mapping, which happens in the relational database. So in this way, in these methods, using depending on our use cases, we can store these URLs in a database. So now let's look into how we actually generate a short URL from a long URL. That is our second topic of today's discussion, that is the hash function. hash function. So the main criteria of hash function, or why do we use the hash function, is like this. Let's say suppose this is f of input x. So like f takes a long URL and it generates a hash value. So if you remember what our requirement was actually in our first video which we discussed, like what would be the contents of our hash value, or what would be the contents of short URL. So it was basically, it would consist of 0 to 9, a to small z, and capital A to capital Z. So this is 10, 26 and 26, which eventually brings up to 62 characters. And also if you remember in our back of the envelope calculation which we also did there, where we considered, like if we again do it in short, like it would have 100 million requests per day, and suppose our URL shortener service, this service runs for 10 years and no data is updated or deleted. So the total number of records that would be generated in this 10 years would be 100 million into 365 into 10, which approximates to 365 billion records, right? So we have 62 characters, and what should be the length? How can we decide the length depending on the 62 characters so that it fits the 365 billion records? So like if I suppose these are the characters, and what should be this length, like 62 to the power n should be greater than 365 billion. So it boils down that if we calculate this value, so the n value stands out to be 7, which supports this expression. So when n equals to 7, that is 62 to the power 7, our value stands at 3.5 trillion, which is greater than 365 billion. Okay, so we got that the short URL to support that much amount of data should have length equals to 7 characters. This is actually the hash value, to be precise, because short URL will have the domain name also and all. So this is our main criteria, main figure which we got from the above calculation. Okay, so now how to create these hash values we will look into. So our question is now is how we create or get the hash values. So for this we will look into two approaches. One is the how we get the hash value, that is from the hash functions. So we will look into two hash functions basically. One is hashing plus collision resolution, another is base 62 conversion. So now let's look into them individually. So first is hashing plus collision resolution. So when we have a long URL, which is our input for this function x, so x is long URL, so we can use any general hash functions which are easily available, like let's say crc32, cyclic redundancy check 32, md5, or simple hashing algorithm 1. All these hash functions we can use to generate the hash values. So let's look into an example of a particular URL. What is the hash values generated by these well-known hash functions, and then we will discuss what is the problem with them and how we have a collision regarding them and how we resolve the collision. So now let's look at an example. Okay, so this is our URL which we are long URL. This is our long URL which we are getting the hash value using these hash functions, and as you can see, these are the values which are generated for our long URL. So even if you see for crc32, the least length is always greater than 7 characters. So how can we make it shorter? So our now question boils down to, for CRC32 the length is greater than 7 characters. How to make it shorter? So for this what we can do is, we can suppose this is our hash value, so we select first 7 characters. We select first 7 characters as our hash value. But this can lead to collisions for more than 2 URLs which are mapping into the similar hash value. Let's say another URL, it maps into some hash value, let's say 405 and 6. But if we do what with our analogy, like we select the first 7 characters, then these two values will match, and 2 different URLs will be having now the same short URL or the same hash value. So to resolve this collision, so this is a collision situation. So to resolve this collision, what we do is we perform an operation recursively. So let's look into the thing as a flowchart. So suppose I have a long URL, I pass it through a hash function, it generates me or gives me a short URL or a hash value. Now I check whether this short URL exists for this corresponding long URL in database. So if it exists in the database, if it doesn't exist, then it's well and good. Let me write down this clearly a little bit. If it exists in database, yeah. So if it doesn't exist in database, so this is well and good, enter into database. But if it exists, this long URL is appended with the, so what we do is we append a predefined suffix or predefined string. This could be any, you can choose it depending on your use case. So like it could be like underscore suffix or hash 001 or something like that. We append it to the long URL and we again recursively put it into the hash function to generate a short URL, and we do it until and unless we get a unique short URL value for this corresponding long URL. So in this way we deal with the collision for this hash and collision resolution. Another thing which we also discussed here and which we'll be discussing right now is base 62 conversion. So let's look into it. What is this base 62 conversion and how does it work? So for base 62 conversion, so if you remember in our database, relational database, how we enter the value is like we have an ID, unique ID, which acts like the primary key, and then we have the short URL, we have the long URL. So before diving into how we put this long URL into our database, let's look into briefly what is a base 62 conversion. So as you are might be aware of, like decimal to binary conversion or hexadecimal to decimal conversion. So similarly, suppose I have a number in decimal 111157, which is represented in decimal, and I want to convert it into base 62. So for this, what we do, before that, suppose I want to convert it into binary. So what we do is like we keep it in the quotient, divide with 2, get the remainder, and in this way, let's say we get some values and we take these numbers and we convert it into this binary from decimal. Similarly, so we have this similar decimal number, we want to convert it into base 62 conversion. So what we do is we divide it by 62, we get the remainder. Similarly, suppose after this I have 179, I again divide it I get the remainder, and the quotient is 2. I will do until and unless it's 0, and I get 2 as the remainder. So now if I map this, as you might be aware, what does this 62 characters denote? So this is basically 0 to 9, A to Z, and capital A to capital Z, all these ranging from 0 to 62. So 59 corresponds to X, 55 corresponds to T, and 2 is 2. So finally what it boils down to is, in base 62 conversion, is 2tx base 62. So if I have a long URL, and the short URL would be like this, would look like tinyurl.com/2tx. But now the question is, how do I get this number? This was for an example, I chose this number, but how does this number come from, and how do we convert that number into a base 62? Is like we use the unique ID, which we mentioned here, to generate the base 62 version of this decimal number. So for that, we have discussed also in the design a unique ID generator playlist how we various methods to generate a unique ID in distributed systems. So this unique ID generated from a unique ID generator, this unique ID now goes through a base 62 conversion, and finally we get some base 62 converted string like this, and this we can append to our URL shortening domain, and finally we can get the short URL. So thus the overall underlying architecture is like we have a long URL and a short URL. So whenever we have a long URL, we want to enter it into the database along with the short URL. What we do is we generate a unique ID, convert to base 62, use this to generate short URL, and after that, using the short URL, using this unique ID and using this long URL, we have a row in our database where the entry looks like this: unique ID, the long URL, and the corresponding short URL. So this is one of our database entry. So if we compare the two methods like which we discussed right now, the one is the hash plus collision resolution, and another is this base 62 conversion, what we actually get is, so this is actually a fixed short URL, fixed length, as we have discussed also, 7 characters, but this varies with the unique ID length, right? Because we every time generate a unique ID and its value may increase every time depending on the unique ID generator, and thus its length is not fixed. Here we do not need a unique ID generator. Here we don't need unique ID generator. Here unique ID generator is needed. Here collision is possible, and we also see how we handle the collision. One thing I forget to mention is like in hash plus collision there is a drawback, right? The drawback is, can you find one drawback here? This database check. So as we know that disk IOs are very resource intensive and very time consuming, thereby incurring high latency, right? So for this is one of the drawback, and to overcome this drawback we can use a method called Bloom filter. So what does it does? Bloom filters, they use probabilistic techniques to check whether a data is present in a set or not. So you can read about this Bloom filter in details. I will post the link about it. You can go through, but this is one of the drawback that we have to check every time in the database, and which might incur some latency. Okay, so let's get back to the comparison. Yes, so this is a collision possible, but here collision is not possible since unique ID is generated every time whenever we enter a new long URL, short URL mapping into the database. Collision is not possible. And another thing is like there's a security concern here. Like, what is the security concern? So that also depends on our unique ID generator, but the main security concern here is if our unique ID increments by 1, we can predict the next short URL, right? Whereas this is not here, whereas this is not possible to predict next short URL. So this is one of the security concern, but this can also be handled if we intelligently choose our unique ID generator for distributed systems. Maybe like we can use the Twitter Snowflake approach or the ticket server by Flickr approach, depending on our use case, depending on the scalability and all, that uses the timestamp to increment the unique ID, and thereby we can also handle this scenario. So this has been a long video, but we have discussed the majorly how the data is being inserted for a long URL, short URL into the database, and how a short URL is actually generated by the hash function and the hash value. How do we handle the collisions and all these things we have discussed in this video. We have discussed two methods to deal with the development of hash values. Like, one is hash values, well-known hash values and their collision resolution methods. Another is the base 62 conversion depending on the unique ID and all these stuffs. So we have discussed the two main points which we introduced initially, that is the data model and hash function. So in the next video we'll be looking into this URL shortening and URL redirecting into details. So thank you for watching this video. See you in the next video.